Okay, so we can move on to creating the temporary tool chain and temporary tools now. So again, there's a couple of points where we've got to change the way the architecture is interpreted, or the compiler is interpreted for the architecture, to ensure that the files go in the correct directory in the lib rather than lib64. Okay, so we've got mnt lib LFS. We're all set up in the sources directory. Let's change into it now. Cd LFS sources. There's all our packages. So let's get on with some compiling now. So bin utils. Now, as I mentioned before, the comparison with the machine I used to compile Linux from scratch 13.0 on, I found that some packages are actually a lot quicker on the ARM and other packages are a lot slower. So one I can think of straight away, I think the bin utils take slightly longer, and the GCC tests especially take nearly twice as long. I think it is at least 50% longer. But there are other packages that take about half the amount of time. So it's obviously to do with the architecture and the way the architecture works, and probably how the code has been written. The code may have been written more for generic Intel, and therefore doesn't work very well on an ARM architecture. So, but overall, it was only a couple of hours longer to build this, 2 or 3 hours longer, and that's mainly because of those GCC tests that took longer. So at this moment for bin utils, there's nothing extra we have to do. It's just a case of copying and pasting the commands. Right, so that's built. I think that takes about 2 minutes instead of 1 minute 45 on the i7 laptop. So just slightly longer. So that's the first package built on this Raspberry Pi. Let's tidy that up and move on to GCC pass 1. And we can just copy this all in. That's all okay. Now here again is where we've got to change the layout or the configuration. So that's the 64-bit allocation, the lib64 for Intel machines, but we want to do the same thing for AMD architecture machines. So let's copy that correctly. Actually, I didn't copy the terminator. So for AArch 64, again it's a sed -e, and I'm looking for MABI.LP64, and I want to substitute, or basically the same. I want to change the lib64 to lib. And the file name is slightly different. So it's in config, but it's arch64, and the file name is t-arch64-linux, and then terminate the case. So what I'm going to do is just double check that that's executed, because there's no output from that, and also just eyeball it in its environment, if you like, just to make sure it looks correct. Normally this would be done with a patch, or it would have been tested in the book, so there wouldn't be any real need to do this unless you're curious as to see what it's done. So here's the change that's happened. It's changed everything after this equal sign to be just in the lib directory, so that to me looks correct. And in fact, if I grep that, was it Oster names? Yeah. So that's the one we've changed. If I check the x86 or the i386 version, the only bit that'll be different is this, because it's different architecture, but this bit you'll see what it was before that change. So if I change this to what it is in the book, you can see that's what it looked like before. It was /lib64, and on our arch one it's changed it to lib. So that looks all good to me. So we can carry on. So make a build directory, configure it, and build. I think it takes about 25 minutes or so. So I'll wait for that to complete. Okay, well that only took just under 9 minutes. It's shorter than I thought. I thought it would be 25. Maybe it's one of the later passes. So let's now install that. And if we check, we shouldn't have the... sorry, we have lib64 at this stage, but we don't have it in the final stage. If you remember, we actually created the lib64, so that's why it exists there. So let's now put this in and move on to the Linux API headers. So, as I've said previously, the Linux we're going to be creating or using rather is the Raspberry Pi Linux. So we need to fetch this, and there's actually instructions on how to do this, how to build it at, where is it? HTTPS raspberrypi.com download, no, sorry, documentation. Computers Linux underscore kernel .html. If I can spell that right. Right, that's better. So this page tells you all about how to compile the kernel and also how to fetch it. So first thing I'm going to do is to will I be able to do this here? Yes, I should be able to. We need to install Git possibly. I think it might already be there. Let's have a look. Yeah, we've already got Git, so we don't need to do that. So we're going to check out Linux from the Raspberry Pi Git repository. And if I open this up, you'll see which version it is we're getting. 6.12.y it's called. Okay, so now we should have a Linux directory. Yeah, there it is. Yeah, there. And what I'm going to do is to rename that and call it Linux RPI and then 6.12.y was it, I think. Yep, 6.12.y. And then I will create a tar archive of that. Not sure if I need to use a P option here for permissions. Yeah, preserve permissions, and it's default for the super user. So tar minus cvp f linux rpi.tar, and be linux rpi inside it, and then I'll compress that as well. So just be a few minutes to complete that. Right, I wonder if I haven't got 80 columns, being that's wrapping around. That doesn't normally happen. So it looks like it's going to be about 6 minutes or so. Okay, let's finish. We should have another archive there now. So there's the original one from the kernel archives, and the bottom one is the one from the Raspberry Pi Foundation. It's a lot bigger, I presume, because it's got some binary blobs in to get things working in the Raspberry Pi. So last thing I'm going to do is I'll have to come out actually, is just change the ownership of that so that it matches everything else. So chown and then I'll go back into LFS, CD LFS sources, and I'm going to, well, let's move Linux 6, move that Raspberry Pi that I downloaded via Git and put it into a backup directory, another directory, so that I can extract this archive that I've just created and test it. Dot tar. So it's extracting, okay, it's extracting into a version directory, which is what I want. So that looks okay. Yep, that looks good. Let's just check that I've got all my settings back in the LFS OK. So I've got the C flags, the make flags, so it looks okay. So I can carry on with that, but before I do that, I'll just delete the other backup that I took. So I haven't got 2 copies floating around. And another thing I'm going to do is, I don't think I could become sudo, can I? No, okay, I'll do this out of here. I'm going to make a directory called do not use, and I'm going to move the standard Linux kernel in there to make sure that I don't accidentally use that one. 6.18 into the do not use, and also grub doesn't get used, so I'm going to move the grub source tarball into that directory as well, just so that it helps me remember not to use that. So su minus LFS, change back into sources, back into the Linux source directory that we downloaded from the GitHub. So I'll leave this tab here because we'll need it right at the very end to build a kernel. There's a slightly different method to building it. But other than that, we can carry on now. We'll have the Linux headers here to create, and we'll have the source to build the kernel later on, as well as the headers, I think, in chapter 8 as well. I think we can use where we extract the headers. Okay, yeah, so we do need the libelf. So yeah, I thought we did. I couldn't remember for sure, but it's because we haven't got the libelf built at all for Linux from scratch. So yes, I was right after all. So let's add that in. libelf-dev. So put that back. Go back to where we were. CD LFS sources, CD Linux, and let's retry that make mr proper, and it's worked now. So now we can do all of this. I'll do one at a time because there's a lot put out to the screen, and just to make sure that this different kernel doesn't behave in any way or produce any errors. That's okay. And finally the copy. So that's all right. So I'll tidy that up as usual. And we can move on to glibc. So straight away we've got another case command where, depending on the architecture, it does different things. So once again, it means we've got to do some different code here for the AArch64. So again, I'm going to copy this in as if I was copying and pasting it from the book, but type in the bit that I need for the AArch64. So the first bit is nearly identical to the x86-64. So I'll just copy that there, but I need to change this name to LD Linux AArch 64.so.1, and it does go to LFS lib 64. And then the second line again is similar but slightly different because different names are used, as well as the architecture name, obviously. So once again, this AArch, in fact this should be here on the disk somewhere, this one. Change that from 2 to 1, and that goes to LD LSB AArch 64.so.3, like that. And then I can copy and paste the rest. Oh, it's just the ESAC. And you can see it's worked. It's detected the correct architecture, and it's created those two symlinks, creating the symlink to the same file, which is exactly correct. So that's that done. We can now do the patch. Create a temporary build, semi-temporary, it is temporary. Build directory and change the config palms and start the configure for the build. Okay, we'll run the build, and I've said this before, I'll say it again, I haven't seen this occur, this note where the parallel make fails for a long time, and I've done lots of oh yes, I forgot all about this. Right, yes, I should have put an O2 in there. glibc has to be compiled with optimization, so it needs to be compiled with an O flag. So I need to edit the .bash rc, is it, I think? Yep. And I need to add in minus O2, which is a standard optimization, and I'll add in a pipe so that it uses memory as well for, I think it's the IPCs. Save that and source .bash profile echo $C flags to check it. Yeah, that's better. So what I'm going to do is I'm going to restart everything that needs to be done inside the build directory. So remove it all. It's all empty. So let's go back up here again. and start doing everything under the build. And reconfigure. Okay, and now this should run. Okay, so that's built, and install it now. Just make sure the LFS system is the LFS variable is set. It is. So let's install. Yeah, I think in my testing I didn't have the C flags set, so I'm hoping that having them set while recording these videos won't cause a problem. Okay, I'll just finish this off now. Check that everything looks okay. Yep, that looks fine. In fact, yeah, that's right. Yeah, that's okay. Arch 64 LFS. Yep, that's good. This should be identical apart from the two lines which have the oh, that's interesting. So the name's wrong there, but that's probably not a big deal because that's only the tools directory. So maybe there's something I've missed setting up there. Yeah, I'm not sure where that would be. But as I said, I don't think that'll be a big issue. Oh, might have been the target LFS. LFS target, actually. LFS target, no, that's correct. Oh, have I done something wrong here? Oh, I've copied and pasted something wrong there. That was the, what have I done here? Grep, that's that one. Grep minus B3. Oh no, it's right. I don't know what I've done there. And the one before, that's okay. I'm not sure what I've done there. I did something ridiculous. Yeah, no, it is right. Tools lib. Maybe this mouse has got a funny, oh no, was it this bit here? No, that's right as well. So yeah, I'm not sure what I did. But anyway, the outputs are okay. Yeah, the mouse has got, the center click has got a bit of a funny thing where it doesn't work sometimes and other times it decides to double click twice. So it seems that every mouse I use doesn't seem to be very durable. So anyway, after all that, that looks fine. Yeah, all these outputs are good. They're mentioning the correct architecture and they look correct as well. Yeah, this is correct. This .so1 rather than .so2. So that's all okay. So we'll tidy that up. And move on to lib standard C++, which is in the GCC package. Okay, let's build that. Okay, so we can install that. Remove these libtool archives, and that's chapter 5 done.